It's all well and good to track and aggregate massive data flows, but what matters most is how many ways you can access it to put it to work. Let's take a look at this side of the formula. For context, let's very briefly recap the many data access methods that SQL Server provides. Now, it all begins and largely focuses upon SQL, the unquestionable leader in data access, supported by Transact SQL or T-SQL, however you prefer to call that, SQL Server's powerful procedural extension. Full text natural language search is also supported, as is XQuery for querying XML data. SQL Server also provides JSON access support through custom SQL to JSON functions. And SDKs are, of course, available for a wide array of languages. But you all know this better than most, so let's move on. So how does Couchbase expose data? Well, applications access Couchbase services directly via our SDKs, which stay aligned with the current shape of your cluster via cluster maps. Key value get-set operations or access to MapReduce views happen through direct contact with any node exposing the data service. On the other hand, nickel queries will be passed to a query service node for planning, which will then interact with the index and data services to complete and return that query. Natural language queries are passed to the full-text search service, which manages and replicates its own unique indexing. Eventing works a bit differently in that it relies on our database change protocol, DCP, to trigger further mutations in response to changes initiated by SDK. Analytical queries are also initiated by SDK and, like the rest, rely on the data service. These methods are accessible not only directly, but also via the offline-first architectures made possible by Couchbase Mobile. And it's worth remembering that although this illustration depicts all services on one node, in reality, your full cluster would be involved, with various services scaled on appropriate hardware, again, all tracked by the SDK cluster map. Couchbase plays nicely with others. We directly support SDKs for virtually every major language, with even more supported by our open source communities. And we directly support connectors for all the major players in the big data ecosystem, including ODBC JDBC drivers. You can learn a lot quickly by scanning the basic profile of our standard APIs. Developers will work with cluster and bucket objects to insert, get, replace, upsert, and remove documents. You can also append or prepend to documents, which is a conceptual entry point to our whole API for subdocument manipulation. We support optimistic locking via CAS, or check and set values. We also support automatic document expiration, which can be managed by extending the TTL, or time to live, for any given document. We support cluster-wide counters, and queries, whether nickel or full-text search, are passed how you might expect. Nickel queries can be assembled manually or via a domain-specific language available in our SDKs. We also support reactive design patterns, including RxJava. As you'd expect, you build your query for either synchronous or asynchronous access, then handle the JSON it returns in the manner appropriate for whichever language you may be using. Full-text search queries are exposed via Sensible API, with many search types supported for the search strings you pass along. Result faceting, limiting, highlighting, and other similar features you'd expect from a full-text search solution are also exposed in sensible ways from within the SDK. Now, because enterprise code commonly happens in a broader context, we also support major frameworks your development teams may well already have in use, such as Spring, for which we support the Spring Data Couchbase project, or .NET, for which we support the Couchbase.NET Link provider. You're already looking at our online training site, training.couchbase.com/online. You'll find beyond these introductory courses, we also have language-specific courses introducing our SDKs for Java, Node.js, C#, and PHP. If you go to developer.couchbase.com, you can find all our documentation. You'll find that we have documentation specific to the SDK for each of these supported languages, as well as some community-supported languages like Ruby. And you'll want to keep your eye on blog.couchbase.com, This is where you can find deep and rich technical articles by the world's best Couchbase experts. So you'll find topics like Couchbase GSI index partitioning in Couchbase 5.5, observability with the Java SDK, X509 certificate authentication, a lot more. So what have we learned? Your applications will connect directly to Couchbase services, wherever they may be in your cluster, via SDK. Your application will have continual awareness of the shape of your cluster via the cluster map. In turn, the services mutually interact as required. We directly support SDKs for 7 major languages, with even more supported in our open source communities. And we directly support connectors for all the major players in the big data ecosystem. Last, we also directly support framework integrations for Spring and .NET. Next up, we're going to get to the heart of one of the biggest questions for any traditional database expert who's exploring the world of document databases. How do tables and documents compare as storage architectures? Come on back.